200,000 years ago, you are standing somewhere in East Africa. You are not a king. You are not a farmer. You are just a person trying to survive the day, watching the horizon for anything with bigger teeth than you. If someone could snap a photograph of you right now and hold it up next to a crowd of people today, one thing would jump out immediately. Your skin is dark. Not tan, not olive. Dark, the way equatorial sunlight demands. So here's the question that sounds simple, but really isn't. If every human being on Earth descends from people who looked like you, where did all the other skin tones come from? Because today, humanity stretches across every shade you can imagine, from the palest skin in Northern Europe to the deepest tones near the equator, with thousands of variations in between. Somehow, one starting point turned into an entire spectrum. And the reason has almost nothing to do with what most people assume. Start with the obvious question. Why was that first human dark-skinned at all? For most of the history of your species, there was no such thing as a white person, a black person, or an Asian person. Those labels are astonishingly recent inventions. For roughly 90% of the time Homo sapiens has existed, almost everyone lived in Africa. And Africa sits directly under some of the strongest sunlight on the planet. That sunlight is dangerous in a very specific way. Ultraviolet radiation doesn't just tan you. It breaks down folate in your blood and damages the DNA inside your cells. Your body's defense against that damage is melanin, the pigment responsible for darker skin. Think of melanin as a built-in sunscreen you never have to reapply. Under equatorial sun, having a lot of it wasn't a cosmetic preference. It was the difference between reproducing successfully and not. Evolution doesn't care what looks good. It only tracks one outcome, whether you survived long enough to pass your genes forward. Under the African sun, dark skin won that contest generation after generation. Then people started walking. Somewhere between 60 and 80,000 years ago, groups of humans began leaving Africa. Some crossed into the Middle East, others pushed into Europe, others turned east toward Asia, eventually reaching Siberia, Australia, and, almost unbelievably, the Americas. No maps, no compasses. Just movement, generation after generation. And as people moved farther from the equator, the sunlight itself changed. Ultraviolet radiation grew weaker the farther north they traveled. At first that sounds like good news. Less radiation damage, less risk. But there's a catch. The same sunlight that damages skin is also what your body uses to manufacture vitamin D, and vitamin D is essential for strong bones and a functioning immune system. Dark skin, so effective at blocking UV in Africa, started blocking too much of it in places where there was barely enough sunlight to begin with. People in northern latitudes who happened to have slightly lighter skin absorbed more of the weak sunlight available and produced more vitamin D. Over thousands of years, that small advantage compounded. Natural selection began quietly favoring lighter skin the farther populations settled from the equator. Here is where the story gets genuinely surprising. The first humans to reach Europe were not pale. Ancient DNA recovered from European hunter-gatherers who lived thousands of years ago reveals something strange. Dark skin paired with blue eyes, a combination almost nobody would expect. The pale skin now associated with Europe didn't appear the moment humans arrived there. It spread much later, as farming reshaped diets, as populations mixed, and as certain genetic variants slowly became more common. Lighter skin didn't win because it was superior. It won because in that specific environment it worked better. Now compare that to East Asia, where a nearly identical outcome emerged through a completely different genetic path. Picture two students who both arrive at the same correct answer on a test using entirely different methods. That's essentially what happened. European populations and East Asian populations both evolved lighter skin than their African ancestors, but many of the underlying genetic mutations responsible are not the same ones. Two separate populations facing a similar environmental pressure arrived at similar results without following the same biological blueprint. Evolution wasn't running one master plan. It was solving the same problem more than once, in more than one way. This is exactly why the old idea of sorting humanity into three simple categories, one for each continent, falls apart under real scrutiny. Human skin color isn't three boxes, it's a continuous gradient stretching across the entire species. North Africans differ from West Africans. Middle Eastern populations differ from Europeans. South Asians differ from East Asians. Indigenous Australians followed their own separate evolutionary route. Every population responded to its own local mix of sunlight, migration, and time, producing not three colors, but something closer to 1,000. And underneath every one of those differences sits a much stranger truth. Trace any two people alive today, whatever their skin color, however far apart their ancestors settled, and their family trees eventually merge into the same trunk. Everyone alive traces back to populations that once lived in Africa. The visible differences that seem so significant today, the ones people have built entire ideologies around, are a remarkably thin layer on top of a species that is, genetically, overwhelmingly similar. Humanity spent far more of its existence looking alike than looking different. The variation you see now represents a tiny sliver of the timeline, a flicker compared to the whole story. That person standing under the African sun 200,000 years ago had no idea Europe existed, or Asia, or that their descendants would one day build cities, launch satellites, and argue with strangers online about categories that hadn't even been invented yet. They were simply trying to survive one more day. And inside them, without any way of knowing it, was the shared ancestry of every person who would ever exist. Every color, every continent, every face. So what color was that very first human? Almost certainly dark-skinned. But that answer is only the opening line of a much longer story. One written slowly across 200,000 years, shaped by sunlight, migration, and the quiet mathematics of survival. And the next time you catch your reflection in a mirror, you are looking at one small variation in an experiment that has been running since the very beginning. Different shades, same origin. One species, painted in every color the sun ever touched.